Recording the vodcast for the Unit 4 practice test on kinetics. My name is Ramsey. Good to see you guys. I'm getting better at drawing in this little thing. I can feel it. Yay. Okay, so going to do the multiple choice first and going to do the free response second. So all AP tests begin with a matching section. Questions 1 through 3 pertain to the reaction A goes to B. Looks like we have rate equals K. Now if there's nothing here, we know this has got to be zero order. There's only something to the 1 power here, so this one's going to be first order, and we have a second order reaction here. So the first one says the natural log, or the ln of A, produces a linear graph. Okay, so that's going to be one that's linear downwards versus time, and we know that is indicative of a first order reaction. So that's going to be B. Just concentration of A versus time produces a linear graph, and that's indicative of a zero order reaction. No matter what the concentration of A is, the slope of the line or the rate of the reaction is constant. So that's going to be A, and by default we have C, but if we had the reciprocal of A, linear upwards versus time, that would be second order. So BAC. The slow rate of a particular chemical reaction might be attributed to which of the following? So slow. A low activation energy. Now that would be a low hill, so the reaction would actually happen fast with a low hill, so that's not it. A high activation energy would be a high hill, and it would take a long time to get over that hill. So that's going to be the answer. We know what catalyst actually lowers the hill, so it can't be a catalyst. Temperature is high, increases collisions, that speeds up the reaction. And when the concentration is high, that increases collisions. So the answer is B. The purpose of striking a match against, the side of a box to light the match is to supply the free energy. Okay, we have not talked about delta G, and we know delta G and rates are not related. To supply the activation energy, okay, to get it to the top of that hill. That makes sense. That's actually going to be the answer. To supply the heat of the reaction. I have not talked about this unit. To supply the kinetic energy. I have not talked about this unit. Catalyze the reaction. This is your distractor, and that's tempting, but we know a catalyst decreases the energy of activation, and a catalyst is a new chemical that's introduced that actually does it, and striking a match is not adding a new chemical. So it supplies the energy needed to get it to the top of the hill. In 6, when the concentration of H plus is doubled for the reaction above, okay, so here are our reactants. We have Mg and we have H plus. There is no change in the reaction rate. Okay, so H, let's say, went from 1 to 2, and the rate, let's say, stayed at 1. So if you line that up, you'd have 1 over 2 to the question mark power equals 1 over 1. So the question mark would have to be 0 in that case. So it's zero order with respect to H plus. Okay, number 7. The energy difference between the reactant and the transition state is. Okay, so again, obviously it's looking, here's reactants, here's products, here's the transition state. This energy difference is called the energy of activation, height of the hill. Free energy is delta G. That is not seen in this at all. Heat of reaction, haven't seen that. The kinetic energy, the reaction energy. If delta H was mentioned here, that would be tempting, because that's delta H. But from reactants to the transition state is the same thing as saying from reactants to the top of the hill. Remember when we did the little demo with our popper? Here was the popper here, and when it was inverted, we called that the transition state. So, anyways, answer C. All right, here we have an experiment. The data in the table above were obtained for x plus y goes to z. Which of the following is a rate law equation? So, for x, we're going to have to find a place where it changes, and y is held constant. So that's going to be 1 and 3. Okay, so let's do that. So x goes from 0.1 to 0.2. and y goes from 4.0 to 4.0. So that's going to be 0.5, so the question mark equals 1, so question mark equals 0. So we know that it's 0 order with respect to x, so x is not going to be in the rate law equation. So it can't be this. It can't be, oh my god. By default, it has to be this. But let's just double check to make sure it is that with respect to y. So here's where this is held constant. So this goes from 0.60 to 0.30. And so we're doing 2 and 3. Question mark power. And this is 1.6 over 0.4. So we're going to get 2 equals 4. Yep. Question mark equals 2. So the answer is B. In a certain reaction, when one reactant is held constant, okay, so we have two reactants, A plus B. When one reactant is held constant, so let's keep this 1 and 1, and the other concentration decreases by 1/4. So let's make this 4 and 1. The reaction rate decreases by 1/16. So let's make this 16 and 1. This data indicates that the kinetics of the reaction is. So notice how I just set up this chart. And I just wrote everything that I saw up there here. So B goes from 4 to 1, question mark, 16 to 1. So 4 question mark equals 16, question mark equals 2. So second order. Which of the following are correct regarding chemical kinetics? Okay. Reactions with a negative delta G always occur quickly. So what they're saying here is that reactions that are spontaneous always happen fast, and we know that's not the case. Ice can melt slowly, spontaneously, and quickly, spontaneously. So it can't be one, boom, boom. All non-spontaneous reactions happen slowly. We know that wasn't the case. When I blew up the hydrogen in class, that was non-spontaneous. Okay, but when I eventually got it to happen over that big activation energy hill, it happened very, very quickly. So reactions that are non-spontaneous can also happen very quickly. So we know that's not the case. So this is the only answer. Catalysts increase rates by decreasing the energy of activation. That's true. They make the hill shorter. Okay, guys. See you on the free response. Take care.